the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is for linear algebra students who are going through eigenvalues and eigenvectors. You should already be very familiar with eigenvalues and eigenvectors and all the basic theory behind eigenvalues and eigenvectors so far. You should also know about what the characteristic equation is and how to find the eigenvalues of a given matrix. Now we're going to step into something called diagonalization. And this video specifically is just for the definition of diagonalization and to talk about some of the concepts of diagonalization without getting into any major theorems, actually any theorems at all. So what does it mean for a matrix to be diagonalizable? Well, a square matrix is said to be diagonalizable if it is similar to a diagonal matrix. Now you should remember what it means for a matrix to be similar to another matrix. It's the same thing as saying there must exist an invertible matrix P such that A gets transformed into a diagonal matrix via the transformation P inverse AP. And like I said, because we're saying that it's diagonalizable, if there exists a diagonal matrix such that A and that diagonal matrix are similar, that just means your transformation from A to P inverse AP will actually transform A into a diagonal matrix. That's all we're saying. Not all matrices are diagonalizable. And by the way, a lot of people think that if a matrix is diagonalizable, it must be invertible. That is not true either. So because this video will not contain any theorems, we're just going to take a little basic example here. Here's a matrix A and a matrix P, and we're going to show that A is similar to a diagonal matrix using this matrix P and its inverse. That is, we want to showcase that P inverse A times P must equal some diagonal matrix D. For right now, I'm not telling you how to find P. We'll get to that in a little bit in another video. It's actually not too terrible. And believe it or not, you've actually been doing it all along. However, let's just check the mathematics here. Let's go ahead and find out what P inverse is. Luckily, we have a nice little 2x2 matrix here. So it's just 1 over the determinant of P, which is -6 minus a -1. So that'd be a -5. And then times the matrix where you get to swap these two entries and you get to negate these two entries right here. That's exactly what I did down here with P inverse. Now I'm actually going to leave my P inverse written that way. However, your instructor might require you to write your invertible matrix like this. I just don't find a need for that, especially when I know what I'm going to be doing. I'm going to multiply P inverse times A times P. And if I could start with P inverse just having all of those 1/5 factored out, I would prefer that. So let's go ahead and find out what P inverse AP is. And there we go. We have verified that the given matrix P does really help out diagonalizing the matrix A. Again, nobody really told us how to find that matrix P. We'd love to know how to do that because really there are some wonderful benefits of being able to diagonalize a given matrix A. In fact, that's what this slide basically says. We want to get a diagonal matrix for multiple reasons. One being the eigenvalues of that given matrix A. It turns out the eigenvalues of the given matrix A, this is something we're going to prove in a follow-up video, but the eigenvalues of A are going to be 3 and -2, and you should be surprised that you see them right there. Also, being able to find the determinant of your matrix A. Well, if it's diagonalizable and you can find the similar matrix to A that is diagonal, then the determinant of A is actually going to be the determinant of the diagonalized matrix. That is, given this matrix A here, even though it's a 2x2, I can quickly compute its determinant. In fact, right now we can easily do it. -12, let's see, +6 is a -6. Well, if you take the look at the determinant of this diagonalized matrix, it's -6. And it's much faster to compute that if you have a diagonalized matrix or a diagonal matrix. And finally, something that a lot of people gloss over is being able to find large powers of a given matrix A. It turns out that's much easier if you can diagonalize your matrix. So there's 3 major reasons why you'd want to diagonalize a matrix. But unfortunately, not all matrices are diagonalizable. So what we're going to do in our next video is actually introduce some ideas behind the scenes as to how we know whether or not a matrix is diagonalizable. And that does it for this very short video. So I hope to see you in the next one. Have a wonderful day. Be a great human being.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.